Jessica Stockham. I'm excited to talk to you about my case study in Spark for ETL. My problem statement is to discover which federal government agencies have the highest web traffic and which have the lowest, and how this varies over time. This is primarily a demonstration of Apache Airflow, which is a tool to orchestrate data pipelines. My data is from the OpenGSA API. I used Python code to pull down the site report for all available federal agencies. The screenshot is of the raw data, which is pulling daily website counts for every agency website domain. Data pipeline. My data pipeline uses Apache Airflow to pull weekly batches from May 1st, 2023 onward. I currently have about 3 million rows of data. Apache Web Server. Here's the Airflow web server for my data pipeline. The top image is the Airflow Directed Acyclic Graph, or DAG, showing the 3 tasks it executes sequentially for me on a weekly basis: to pull the data, to transform the data, and visualize the data. The bottom image shows the schedule for my API DAG. The schedule uses the cron tab syntax. The 3017 means I'm running the job at 17:30 UTC, or 5:30 p.m. Universal Coordinated Time. I'm doing it on day 1, which is Mondays. High-level results. The most visited agency in 2023 was the Department of Health and Human Services. The least popular agency was the Nuclear Regulatory Commission. And here is a visualization of all my data. Thank you. My name is Jessica Stockham. I'm excited to talk to you today about my case study in Spark for ETL. My problem statement is to discover which federal government agencies have the highest web traffic and which have the lowest traffic, and how this varies over time. The target audience is federal agencies. Why does this matter? Federal agency websites that have little traffic may be poorly designed or not well publicized. When websites have very high traffic, the government needs to be prepared to meet both the high website infrastructure demands and the downstream service delivery requirements. This is a demonstration of the Apache Airflow software. I also used Python, including packages like the requests to pull down the API data and Altair to do the data viz. The main workhorse to ingest and transform the data is Spark via the PySpark interface. I also stored the data in my SQL database. The data is from the OpenGSA API. I used Python code to pull down the site report for all available federal agencies. There are 27 of these that post their data. The screenshot on the bottom is a screenshot of the raw data, which shows daily visits for every website domain, for example, justice.gov or dea.gov. The screenshot shows daily website visit counts for May 1st, 2023. Data pipeline. So first, before we get into the pipeline, I did pull down a large batch of historical data from 2019 through April 30th, 2023. And then starting on May 1st, 2023 onward, that's when I used Apache Airflow to pull weekly batches. As of the latest pull on May 8th, I have about 3 million rows of data. The infographic on this slide shows the basic steps in my data pipeline. Extract the data and pull it down to a PySpark data frame and write the data to a MySQL database. I also transform the data for analysis in PySpark, aggregating up daily data to monthly counts for each agency. I then use Python's Altair package to create a heat map to visualize the monthly data for each agency. The heat map provides the big picture. The text on the bottom of this slide shows which Python scripts are associated with each step in the pipeline. API pull code snippets. Just quickly, here's a snip of the part of the code I used to pull data from the API. I'm using the Python request package and submitting several parameters to the API, including the limit parameter. For example, I'm using a limit of 10,000, where I'm saying I want the maximum number of data points you can give me with each query, because they only let you take a maximum of 10,000. The page parameter is used for pagination when there are more than 10,000 data points I need for a given query. And then the after and before parameters define the date range of the data pull. And there's lastly, of course, my API key, which I need to send with the request. Let's look at the more interesting code next, which is the Airflow code to create the DAG, or Directed Acyclic Graph, to schedule my data pipeline. A DAG defines the tasks to be performed in the order in which they should happen. My DAG code file is called api_dag.py. We can break this code into 3 segments. The top chunk of this code up here defines the schedule for the DAG, which uses a cron tab syntax. This 3017 means I'm running the job at 1730 UTC, or 5:30 p.m. Universal Coordinated Time. And I'm doing it on this last one, day number 1. Day number 1 is Monday, so I'm doing it every Monday. The second chunk of code defines the tasks I want to run each week. Each of these tasks is executed using the bash operator, which means I'm executing a bash command. For the Spark scripts in tasks 1 and 2, I'm using the Spark submit bash command. In task 3, I'm just using a Python script, so I'm using Python 3 bash command. At the very bottom is how I set the order of operations of the tasks. You can simply use the double caret operator here. My order of tasks goes from left to right. So first I'm going to do the API pull, then transform, then visualize. Let's take a look at the Airflow web server. You can see my API DAG listed here on the API web server. The web server is at localhost port 8081. It provides this nice GUI interface to view the DAG schedule and the previous runs and the next scheduled run. You can see the last run was on Monday, May 8th. So the next run will be on Monday, May 15th. This below here is the graph view. You can see the order of tasks to be submitted sequentially in my DAG to pull through the API, then transform, and then visualize. High-level results. So what I found is, at least in 2023, the top agencies for website hits were the Department of Health and Human Services, the Postal Service, Commerce, and Treasury. The least visited agencies were Nuclear Regulatory Commission, U.S. International Development, the National Science Foundation, and Housing and Urban Development. Let's take a look at the visualization that shows this big high-level picture. So this is a heat map that shows all my data up to the latest batch pull. You can see through 5/7/2023. The way the colors work on this heat map is the darker the blue, the more website hits. And you can see that each agency is listed on the y-axis and the months of the year are listed on the x-axis. And you hold your mouse over each box and it shows you the individual data for that data point. You can see that over the years, the Department of Health and Human Services has really been consistently popular. You can see a very high hit around the start of the COVID pandemic in February, March 2020. You can also see the Postal Service has been quite popular all through the last few years, particularly so at the end of 2020, which is interesting. The Treasury also has some peaks, which makes sense as we see some peaks towards tax season every year, and interestingly, particularly so in years 2020 and 2021, the kind of COVID years, and less so in 2022, actually, and in 2023. Another interesting agency is Commerce, which shows a pretty high, strong pattern every month through the last few years. So these are areas to investigate further. Okay, so let's talk about lessons learned. In general, I think the biggest lessons learned was start as simple as possible when learning a new tool. Make sure a basic trivial example is working before you launch into your project code. Then, after the trivial thing is working, test every little step in your code in your data pipeline before you string it all together. This really helped me to troubleshoot issues as I came across them. Second, there are some specific kind of technical glitches I encountered with Apache Airflow. Not really glitches, just things I didn't know. So one is the Airflow uses the UTC time zone for scheduling jobs, not your local computer's time zone. So this threw me off for a day. Second, is if you want your DAG to start running right away, make sure that your start date in your schedule is far enough back. For example, if you want your weekly batch job to start today, make sure your start date is more than 7 days in the past. This tripped me up for the longest time for several days when I couldn't get my first batch job to work. Finally, if you need to change something in the configuration file, airflow.config, after you're done, you need to reset the Airflow database and also shut down and restart the web server and scheduler before you're ready to get going again. So I have lots of ideas to expand this work. One is just working more with the GSA API. They have a lot more data I did not pull. One is to pull the device report so you can see how users interact with the content, are they using their phone, are they using their desktop. You may be able to identify anomalies. For example, maybe the mobile format is terrible for a particular domain, and we can identify that through this kind of analysis. I'd like to also conduct detailed trend analyses and visualizations at the agency level for individual website domains. So let's see which websites in particular are popular at which times of year. I'd also like to pull in different kinds of data into my data pipeline. One is economic data, to integrate weekly stock market data, monthly jobs reports into the data pipeline. So to ask questions like, how does the economy correlate with the demand for particular federal websites? I'd also like to bring in Twitter data to understand how various topics of interest for each agency evolve over time, and if certain topics are correlated with higher website hits. You can pull out topics of conversation, look at the number of followers. We might also use Neo4j to conduct a network analysis of key influencers. And lastly, I'd like to serve this all up on a website so it can be reviewed by federal government workers. Great, and here's my short YouTube 2-minute video and GitHub repo links. Thanks for your time.